So how do we take a three-dimensional landscape and turn it into something like this? That's a topographic map, and I'm going to show you guys how we can understand what a map like this means in relation to a three-dimensional landscape like this. So what are we going to do here? We're going to be using some water, and we're going to be helping identify different elevations and then creating a map of this three-dimensional structure. So let's get started. All right, so first I've got 1,000 milliliters of water here, and to get started, just to help us out, I'm going to get 300 milliliters and pour it in just to kind of get a little bit of a baseline to help us make our map. This will just get to the, I guess what we would call a height of 0 or elevation of 0. We can call this our sea level. Okay, so once we have that, what we're going to do is we're going to put this on top. Now from this angle, it does not look like this lines up at all, but when I go, let's see if I can make this work. When I go like this, this is where, this is going to be a little tricky to try. There we go. I'm going to then go in and draw where the water hits. So I'll just do this on my own, and then we'll come back and look at it. So now you can see that these little dashed lines here should line up where the water is. And I'm kind of trying to, there we go, like that. That's how it looked from my point of view. So the next thing we're going to do is we are going to add some more water to represent a new elevation. I'm going to be measuring out 150 milliliters. So here's my 100 milliliter beaker, and I'm going to pour it in. There's 100 milliliters. Let's get my 50 and pour that in. And we're going to see where that meets our landscape. Now, this one actually doesn't seem to have done very much, but let's just double check. Okay, so we can see that the water level has risen, so I'll add my line. Actually, I'm going to leave it like this for now. So we're going to add a little bit more because it really didn't change our elevation marker. So we're going to start adding our 150 milliliters again. Here is our first 100 milliliters. Oh, there we go. We're starting to see some interesting changes as we add more water. Here's my 50 milliliters. Okay, it should look a lot different already from before. So now let's replace this and let's add to our map. So you'll see that the water is actually hitting the landscape at a different point right now. And so we're going to call this an elevation of 1. So what I'll be doing is drawing my lines on my map to represent where the water hits here. Now water is going to always be flat, right, across the top, because it fills up the volume of the space that it's in. So it's going to kind of level its own self out. So what that indicates on our image then is that wherever this water is hitting, it's going to be representing that elevation or that height on the landscape. Because the water is just flat everywhere, we know that it's going to be a good, kind of like a laser level almost, without having to use the light. That the water itself becomes this kind of marker of elevation. So let's draw it on my map. So what I did is I traced it. It's kind of off. There we go. Well, it looks a little better, I guess, maybe from my eyeballs. But I'm going to write down that these are a height or elevation of 1. So now I'll repeat the same thing. I'm going to use my 150 milliliters of water, and I'm going to add it into our model and see what happens with the elevation change. Here's our first 100 milliliters. You'll notice a difference already. And then here comes my additional 50 for my 150. All right, again, already observing it with my eyes, I notice that it's different, but now I'll compare it with my map that we've made originally. You can see it is different. So I'm going to take a second here and draw my new lines to indicate where the new elevation is, because as I added the water, it increased its height inside of this container, which is representative of an increase in elevation on the landscape as well. So I traced my shapes kind of close there, and I wrote a 2 next to them because this is now my elevation of 2. It's the second height of the pores that I put with my water. So it's showing a different elevation on our map. And you can see our map is starting to sort of look similar. I mean, this is not the same structure or landform, but it's getting a similar look to this. So let's move on and do our next pores and see what happens. Okay, here's my first 100 milliliters, and I will add 50. You'll notice that I'm not pouring it directly on the landform, and that's just because there are some depressions you'll see. This looks like it might be a little volcano crater or something. I don't want to pour my water in and then have a misinterpret that information. So I'm just going to pour it off to the side and let the water naturally fill in. Now, obviously, if there are some little natural depressions, maybe my map's not going to be perfect, but for the purpose of just learning how to make a map like this, this will work just fine. All right, so I see this, and I don't know, I can try and risk. No, I'm going to pause it and do it with my own eyeballs, and we'll see what it looks like. We can take an inference, though, or make a guess of what it'll look like based on what you see with where the white is exposed and where the water's touching it now. Let's see how it looks. All right, so there are my lines. Again, kind of looks different from the camera than my eyeball. There we go. That's kind of what it looked like for me. And I wrote a 3 next to these because this is the third elevation from the third water pour. You'll notice that every time I pour water, it's going higher and higher on the little structure underneath, the landform underneath. And so when we pour that water, it's helping us to see where that height is changing, right? Because if I just kind of guessed with my own eyes, I wouldn't know for sure, but the water touches every part of the landform and helps inform that. All right, let's do our next pour. Okay, here's 100 milliliters. And finally, my 50. Okay, let's put our map on. Let's take a look. And I see there's one little part exposed. So let's draw that on. So there I see my height or elevation of 4. Oh, there we go. And I see just a little bit of the mountaintop still exposed. Now, if I were to pour another 150 milliliters, we could predict that perhaps, that would be covered up. So I could give that a try and see what happens. And here is 100 milliliters. Oh, and there it got covered. So I can't even pour the full 150 milliliters. So we're going to call this done, because each line should represent 150 milliliters. And because we can't pour 150 milliliters to create a new line, that the elevation of the tippy top of this peak is somewhere between the 4th and the 5th line. Let's take a look. All right, so this is now our topographic map, and this was the landform. Let's go and let's take the water out. Although it is kind of cool to see the color variation, and some topographic maps actually will be differently colored. So you can see that the darker spots indicate kind of where there's more water, it's deeper, and then you get these lighter spots where the elevation is higher because there's less water covering it. That's actually kind of a neat way to also make some observations about the topography of the landform. All right, now I want you to keep a couple things in mind. Well, let's pour out the water and take a look. Okay, when I look at these two maps, this now is a two-dimensional representation of this. And there's a few things to think about. If we would have poured less water at a time, we probably would have seen, like you can see, that this object or this part of the landform has some different shape here than our map over here, and that's okay. It would just be a more detailed map had we used fewer amounts or lesser amount of water each time. So this map isn't quite as detailed, and that's good to note. But what do we get from this? Well, we can see a few things. Let's take a look at them side by side. I can see the general shape of the land, so I can see the shape. I see these lines here, which also show elevation. And lastly, well, maybe not lastly, but importantly, look at this. Do you see how, this part of the structure is really, really steep? And I notice here that our lines are a lot closer together than maybe on this side. So I can see the steepness. If I had a scale for this, like I knew that, this was so many meters across this whole structure, I would also know the distances between things. So, I don't actually have that right now, but I can see shape, elevation, steepness, and distance. So what do I see? I can see, again, the shape. and that indicates if this is a mountain or a hill or a cliff. I can see how tall structures are, like this part here is the tallest part of the whole structure because it has this elevation up to 4, where this is only at a 1, so I know that this is the tallest part. Now going with the shape, usually with these concentric kind of circles, it indicates something either climbing upward or going down. And because my numbers are going from 1, 2, 3, 4, I know that this is getting taller, like a mountain peak. If the numbers were reversed, going 4, 3, 2, 1, I know that that would be some sort of a hole or a valley. In terms of steepness, when the lines are close together, it represents, just like over here, a really steep increase because it's showing a change in elevation. And lastly, the distance. I can see how far these are, but I would need a key, so that would look something like this. Like that would be, 50 kilometers or whatever the key might be. So, using water, we can take information from a three-dimensional structure and translate that to a two-dimensional structure that can help us to understand the land around us and interpret several things like shape, elevation, steepness, and distance so that we would be able to understand the landscape in a nice two-dimensional package instead of having to have a three-dimensional model with us.